Task 3.1. Research, implement, and manage engineering processes using secure design principles, a crucial area for the exam and your career in information security. Now, before we begin, let me remind you that if I don't go as deep as you hoped on anything in this task, use the prompt at the end of the session to get your favorite AI assistant to go deeper and test your knowledge. So let's get started. Alright, this task has 11 subtasks, so let's get started. Number 1, threat modeling. 2, least privilege. 3, defense in depth. 4, secure defaults. 5, fail securely. 6, segregation of duties. 7, keep it simple and small. 8, zero trust or trust but verify. 9, privacy by design. 10, shared responsibility, and 11, secure access service edge. As we discuss each principle, you'll notice that many concepts overlap and interconnect. This isn't repetition for its own sake. It reflects the reality that security is a holistic system. Understanding these interconnections is crucial for success on the CISSP exam and in your security career. 3.11 Threat Modeling. Threat modeling is a crucial process in the CISSP's toolkit for identifying and addressing potential security risks. For the exam, you need to understand that threat modeling is a proactive approach to security, implemented early in the development lifecycle. Key points to remember about threat modeling for the exam. 1. Methodologies. Familiarize yourself with common threat modeling strategies and methodologies like STRIDE, spoofing, tampering, repudiation, information disclosure, denial of service, elevation of privilege, DREAD, damage reproducibility, exploitability, affected users, discoverability, and PASTA, process for attack simulation and threat analysis. 2. Process steps. The threat modeling process typically involves system decomposition, threat identification, mitigation strategies, and validation of the model. 3. Proactive security. Emphasize that threat modeling allows teams to prioritize and address risks early, potentially saving time and resources later in the development process. Challenges. Be aware of common challenges in threat modeling, such as keeping models up to date as systems evolve, handling complex systems with numerous components, and avoiding overcomplication that could hinder implementation. Remember, threat modeling isn't an isolated process. It interconnects with other principles we'll discuss, such as defense in depth and zero trust, as it informs how these strategies are implemented. For the exam, you should be prepared to analyze scenarios where threat modeling is applied and identified, and most appropriate actions based on threats identified. Subtask 3.1.2 Least Privilege. The principle of least privilege is a fundamental concept for information security and a topic on the exam. The principle states that users should be granted the minimum level of access and permissions necessary to perform their job functions. Key points to understand about least privileges on the exam is 1. Access limitation. The core idea is to limit user access rights to only what is strictly required for their roles. This minimizes the potential for damage from accidents, errors, or malicious actions. 2. Regular reviews. Emphasize the importance of conducting periodic access right reviews. As roles change, access rights should be adjusted accordingly to maintain the least privilege stance. 3. Implementation strategies. Role-based access control, RBAC. Assign access rights based on predefined roles within an organization. Attribute-based access control, ABAC. Grant access based on other user attributes such as time and location. 4. Dynamic adjustments. In modern environments, least privilege often involves continuous context-aware adjustments to access rights based on changing roles, responsibilities, and risk factors. 5. The benefits. Reduced attack surface, minimized impact of breaches, improved system stability, and enhanced regulatory compliance. And remember, least privilege is not an isolated concept. It works in conjunction with other principles that we'll discuss, such as segregation of duties, zero trust, to create a comprehensive security posture. Subtask 3.1.3, Defense in Depth. Defense in depth is a critical security strategy you'll need to thoroughly understand for the CISSP exam. This principle advocates for layering multiple security controls to protect an organization's assets. Key points to remember about defense in depth for the exam. 1. Multiple layers of defense. The core concept is to implement various security measures at different layers of the system or network. This approach ensures that if one layer fails, the other layers can still provide protection. 2. Redundancy. Emphasize the importance of overlapping security controls. This redundancy helps ensure protection even if a single control fails or is bypassed. 3. Diverse strategies. Defense in depth incorporates a variety of security techniques and tools such as firewalls, intrusion detection systems and intrusion prevention systems, anti-malware software, encryption, access controls, and physical security measures. 4. Continuous monitoring. Highlight the need for regular monitoring of all layers to detect and respond to security incidents promptly. This ties into the concept of trust but verify that we'll discuss later. Adaptability. Stress the importance of updating and adapting security measures to address the emerging threats and vulnerabilities. Defense in depth is not a static strategy, but an evolving one. 6. Holistic approach. Remember that defense in depth extends beyond just the technical controls. It includes administration and physical controls as well. For the exam, you should be prepared to analyze scenarios and identify how defense in depth can be applied effectively. You might be asked to evaluate the strengths and potential weaknesses of a given security architecture. It's important to note how defense in depth interconnects with other principles we've discussed or will discuss. For instance, it works hand in hand with threat modeling to identify where layers of defense are needed and supports the principle of fail securely. Subtask 6.1.4, Secure Defaults. The principle of secure defaults is crucial for the exam, and it emphasizes the importance of configuring systems and applications with the most secure settings right out of the box. Some key points to understand about secure defaults for the exam. 1. Default settings. Stress that systems and applications should be configured with the most secure settings by default. This approach shifts the burden from users having to enable security features to having to deliberately disable them if necessary. 2. Minimal permissions. Highlight that secure defaults involves applying minimal permissions and access rights by default. This aligns closely with the principle of least privilege that we discussed earlier. 3. Disable unnecessary features. And the importance of turning off or disabling unnecessary services and features by default. This reduces the potential attack surface of the system. 4. Benefits. It reduces human error in security configurations. It ensures a baseline level of security even with unexpected or inexperienced users. And it simplifies the process of maintaining a secure posture. 5. The challenges. Balancing security with usability. Ensuring defaults are appropriate for various use cases, and keeping default configurations up to date with evolving threats. 6. Implementation. Secure installation processes, well-configured templates for new systems or user accounts, and regular audits to ensure defaults remain secure. For the exam, be prepared to analyze scenarios where secure defaults play a crucial role. You might be asked to identify potential vulnerabilities in systems where secure defaults haven't been properly implemented. Remember, secure defaults isn't an isolated principle. It works in conjunction with other principles that we've discussed or are about to discuss. Subtask 3.1.5, Fail Securely. The principle of fail securely is a crucial concept for the exam. It emphasizes that when systems or applications fail, they should do so in a way that maintains security and doesn't create new vulnerabilities. Key points to remember about this. 1. Default to a secure state. Stress that systems should default to a secure state in the event of a failure. This means that if something goes wrong, the system should err on the side of denying access rather than granting it. 2. Error handling. Emphasize the importance of robust error handling and logging mechanisms. This should be designed to avoid exposing sensitive information that could be exploited by attackers. 3. Graceful degradation. Highlight that systems should be designed to degrade gracefully, maintaining core security functions even when parts of the system fail. This ties into the concept of resilience, which is crucial for information security. 4. Redundancy. We're going to discuss the role of redundant systems and backups in ensuring continued operation and security during failures. This connects back to the defense in depth principle we discussed earlier. Examples of fail security implementation: firewalls defaulting to closed states if they crashed, authentication systems denying access if they can't verify credentials, encryption remaining in place even if access controls fail. 6. Challenges. Balancing security with availability. Ensuring fail-secure mechanisms don't create denial of service vulnerabilities, and testing fail-secure implementations thoroughly. For the exam, be prepared to analyze scenarios where systems fail to identify whether they're failing securely or not. You might be asked to evaluate the potential consequences of different failure modes and suggest improvements. And remember, it's not an isolated principle. It works in tandem with other principles we've discussed, such as secure defaults and defense in depth, to create a comprehensive security strategy. Subtask 3.1.6, Segregation of Duties. It's an important and crucial topic for both the exam and information security in general. 1. We're going to separate privileges and responsibilities. The core idea is to ensure that no single individual has control over all aspects of any critical process. The separation reduces the risk of fraud, errors, or malicious activities. For example, the person who approves purchases shouldn't be the same person who reconciles bank statements. 2. Access controls. Implementing SOD requires robust access control mechanisms. We need to limit permissions so that individuals can only access functions relevant to their specific role. This ties back to the principles of least privilege that we discussed earlier. 3. Role assignment. To effectively implement SOD, we use techniques like RBAC and now ABAC. These mechanisms help us assign tasks and responsibilities in a way that ensures proper segregation and reduces risk. For the exam, you should be prepared to analyze scenarios and identify whether SOD is properly implemented. You might be asked to spot potential vulnerabilities in processes where SOD is not adequately enforced. Task 3.1.7. Keep it simple and small. The principle is a fundamental concept in secure system design and an important topic on the exam. The principle emphasizes the value of simplicity in creating and maintaining secure systems. So let's focus on 4 key areas. 1. Minimalistic design. When designing systems or processes, implement only the essential features. This minimalist approach helps reduce complexity and consequently potential vulnerabilities. Remember, every additional feature or function is a potential entry point for attackers. 2. Simplified code. In software development, writing clear and concise code is crucial. This approach helps minimize errors and improves maintainability. Complex, convoluted code is more likely to contain bugs and security flaws that can be exploited. 3. Limit functionality. It's important to restrict system functionality to only necessary operations. This reduction in the system's capabilities helps minimize the attack surface, making it harder for potential attackers to find vulnerabilities to exploit. 4. Easy management. Ensure that systems and processes are straightforward to manage and understand. This simplicity makes it easier to maintain security over time, as complex systems are more prone to misconfigurations and oversight. For the exam, you might encounter scenarios where you need to evaluate system designs or processes. You should be prepared to identify overly complex elements and suggest ways to simplify them without compromising functionality or security. Remember, keep it simple and small. Interacts with other principles we've discussed. Subtask 3.1.8, Zero Trust, or Trust but Verify. This is a crucial modern security paradigm and important topic for the CISSP exam. The principal challenge is the traditional security model of implicitly trusting entities within a network perimeter. So let's focus on four key aspects. 1. Verify always. In a zero trust model, we continuously verify the identity and integrity of users and devices regardless of their locations. This means that if a user or device is inside a corporate network, they're not automatically trusted. For the CISSP exam, understand that this continuous verification applies to all network traffic and access requests. 2. Least privilege access. Ties back to our least privilege that we discussed earlier. In zero trust environment, users are given the minimum level of access required to perform their task. This minimizes exposure and potential damage in case of a breach. 3. Microsegmentation. This involves dividing the network into small, isolated segments. Each segment has its own security controls, and traffic between segments is strictly controlled. This approach helps contain breaches and reduces the risk of lateral movement within a network. For the exam, understand how microsegmentation contributes to overall network security. Continuous monitoring. Zero Trust relies heavily on continuous monitoring analytics to detect and respond to threats in real time. This involves analyzing user behavior, device health, and network traffic patterns to identify anomalies quickly. The exam might test your understanding of how continuous monitoring supports a zero trust model. And remember, zero trust or trust but verify is not just a set of technologies, part of a holistic approach to security. It intersects with many of the other principles we've discussed or are going to discuss. Subtask 3.1.9, Privacy by Design. It's a crucial concept in modern information security, an important topic for the CISSP exam. This principle emphasizes that embedding privacy measures into the design and architectures of systems and processes from the very beginning. Let's focus on four key aspects. 1. Embedded privacy. The core idea of privacy by design is to integrate privacy measures into the design and architecture of a system and processes right from the start. This proactive approach is more effective than trying to add privacy features after a system is already built. For the exam, understand that privacy should be a fundamental consideration in all stages of system development and operation. 2. Data minimization. This aspect focuses on collecting and processing only the data necessary for the intended purpose. By limiting the amount of data collected and stored, we reduce the potential exposure and risk in case of a breach. The exam may present scenarios where you need to apply minimization principles to enhance privacy. 3. User control. Privacy by design emphasizes providing users with control over their data. This includes options for consent, access, and deletion of personal information. Understanding how to implement these user controls and their importance is crucial for the exam. And 4. Proactive measures. This principle advocates for implementing proactive measures to identify and mitigate privacy risks before they result in harm. This could involve conducting privacy impact assessments, implementing privacy-enhancing technologies, and regularly auditing data handling procedures. The CISSP exam may test your ability to identify and suggest proactive measures in various scenarios. Subtask 3.1.10, Shared Responsibility. Shared responsibility is a crucial concept in cloud computing environments and an important topic on the exam. The principle delineates the security responsibilities between cloud service providers and their customers. So let's focus on four key areas. 1. Division of security duties. In a shared responsibility model, it's critical to clearly define and assign security responsibilities between the cloud provider and the customer. This ensures comprehensive coverage of all security aspects without gaps or overlaps. For the exam, understand that the exact division of responsibilities can vary depending on the service model, as an infrastructure, platform, or software as a service. 2. Customer data responsibilities. A key point to remember in the exam is that customers almost always are responsible for securing their data, regardless of the cloud service model. This includes responsibilities such as data encryption, access controls, and backup. Even in SaaS models, where the provider manages most of the stack, data security ultimately remains the customer's responsibility. 3. Provider responsibilities. Cloud service providers typically handle the security of the physical infrastructure, network, and underlying platform. This includes the physical security of data centers, network infrastructure security, and the security of virtualization layers. The exam may test your understanding of where the provider responsibilities typically end and customer responsibilities begin. 4. Compliance and risk management. Effective implementation of the shared responsibility model helps in meeting regulatory requirements and managing security risks. It ensures a secure cloud environment by leveraging the expertise of both the provider and the customer. For the exam, understand how shared responsibilities contributes to an overall risk management and compliance efforts. Remember, shared responsibility model is not a one-size-fits-all. It's based on the cloud service provider, the specific provider, and the negotiated agreements between the provider and the customer. For the exam, be prepared to analyze scenarios involving cloud services and determine the appropriate division of security responsibilities. You might also be asked to identify potential security gaps or overlaps in shared responsibility implementations. Subtask 3.1.11 Secure Access Service Edge. This is relatively new, but an important concept in network security designs, and it's likely to be covered in the CISSP exam. 4 key bullets I want to cover. 1. Unified security. SASE integrates various network security services such as secure web gateways, cloud access security brokers, and zero trust network access into a single cloud delivered service model. For the CISSP exam, understand that this unified approach aims to simplify security management and improve overall protection. 2. Zero trust. It implements zero trust, which we discussed earlier. In this context, it means verifying each user and device regardless of their location or network. This aligns with the never trust, always verify principle. The CISSP exam may test your understanding on how this incorporates the zero trust model. 3. Dynamic policy enforcement. SASE uses real-time context to enforce security policies. This could be based on user identity, device health, application being accessed, and other contextual factors. For the CISSP exam, understand how this dynamic approach differs from traditional static policy enforcement. And 4. Scalability and performance. SASE leverages cloud infrastructure to provide scalable security that meets the demands of distributed workforces and applications. This aspect is crucial for supporting modern cloud-first organizations. The CISSP exam may ask about the benefits of this cloud-based approach compared to traditional on-premises security solutions. Remember, SASE is designed to address the secure challenges of modern distributed networks where traditional concept of network perimeter is becoming obsolete. Alright, summarizing task 3.1, research, implement, and manage engineering processes using secure design principles. Let's recap some key points. Threat modeling and risk mitigation. We've explored how to implement key security principles like threat modeling, least privilege, and defense in depth to identify and mitigate risks. These form the foundation of proactive security measures that are crucial for the CISSP exam and real-world practice. 2. Simplify and secure. We've discussed the importance of applying secure defaults, failing secure, and keeping systems simple and small. These principles help enhance security by reducing complexity and the potential attack surface. Remember, for the exam, you need to understand how these concepts work together to create a more robust security posture. And 3. Accountability and access control. We've covered the use of segregation of duties to reduce risk and ensure proper access controls with RBAC and ABAC. These concepts are fundamental to maintaining a secure environment and are frequently tested in the exam. Remember, these principles are not isolated, but interconnected parts of a holistic approach. The CISSP exam will test your ability to apply these principles in various scenarios and understand their relationships. All right, have fun. Use your prompt. Use your AI, LLM assistant, your favorite one. It doesn't matter. I personally have loved that ChatGPT remembers a bunch of context about me. That's kind of cool. I do find that Claude tends to not hallucinate as much. It might get a little verbose, but you play with it. Remember, we all get smarter together. You're training them, they're training you. And play with that step 5 over here and deep dive into any topic you feel I didn't go deep enough for. Bye-bye.